everyone, I Kruti Jai Pancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Analog and Digital Communication System. From this video, you will learn about ideal high pass and band pass filter characteristics, signal distortion over a communication channel. In the last lecture, we learned about the ideal low pass filter as well as the impulse response of a ideal low pass filter. Ideal filter allows distortionless transmission of certain band of the frequency and suppress all other frequency. Ideal low pass filter that allows all the components below f is equal to b Hz to pass without the distortion. We have also learned about the characteristics of the low pass filter, that it also allows the component which is less than 0, mean the t less than 0. Here it is the response about the ideal high pass filter. Ideal high pass filter that will allow the frequency that is above f greater than b Hz. This is the phase response of the ideal high pass filter. Ideal band pass filter. These are the two band of the frequency that can be allowed for the transmission while we go for the ideal band pass filter, and it is the characteristics of the phase response for the band pass filter. As we know that the impulse response of an ideal low pass filter that provides us the component that is less than 0 also. So ideal low pass filter that will act as a non-causal system, that will be used for the non-causal response, that which provides us the response for the future values also. And the realization of such kind of the filter that is also not possible. So impulse response of an ideal low pass filter that exists even before the instant t is equal to 0. So ht is not equal to 0 for t less than 0. So ideal low pass filter is a non-causal system, and a non-causal system cannot be practically realized. The ideal low pass filter that can be again not possible to design. So design of the practically or the physically reliable system. So for the physically reliable system, what should be the value of ht? The ht value that is equal to 0 for t less than 0. So in order to achieve this impulse response ht of the ideal low pass filter is cut off for t less than 0. So ht will exist only for the t greater than 0. So now we want to modify the impulse response of a low pass filter, and we have to make ht 0 for the t less than 0. So this is the impulse response of the practical low pass filter. We need to cut the tail of the ideal low pass filter. By cutting the tail of the ideal low pass filter, over here you obtain the impulse response of a practical low pass filter. So the resulting causal impulse response is mathematically represented as ht is equal to ht into ut. So by multiplying with the unit impulse signal, we can have the ht signal. So the low pass filter which has this type of the response is called the practical low pass filter. So practical low pass filter that is having the close approximation with the ideal low pass filter. and whatever the value of this TD, that is the width of the pulse, then better is the approximation. So our TD that tends to infinitive, the filter tends to become the ideal filter. This is the characteristics of the ideal filter, and this is the practical filter. So this way we can go for the realization of the practical filters while we need to use it for the communication. The next point is signal distortion over a communication channel. While the signal that can be passed through any communication channel, the signal that can be distorted. Signal that can be distorted. How the signal that can be distorted? So there are the various causes due to which the signal that can be distorted. So there are the 4 different points, okay, in the types of the signal distortion. One is the linear distortion. Another is the distortion due to channel non-linearities. Distortions due to multipath effect. Distortions due to fading channel. Now the first point, linear distortion. Before starting the linear distortion, what is a distortion? So due to the non-ideal channel, the transmitted signal changes its form or a shape, thus resulting signal in the perturbation, this is called the distortion. So whenever the signal that can be passed through the communication channel, sometime due to the distortion, either the amplitude or the frequency or the phase of the signal, if it is changed, then it can be considered as a distortion. So what is a linear distortion? So it is defined as a change in the amplitude or a phase with no new frequency added. So in the distortionless transmission, the magnitude response or the amplitude response of the channel should be flat. I mean, if there is no distortion, the magnitude response that is flat, whereas the phase response should be linearly proportional of the frequency. Next category is distortion due to non-linearities. The non-linear distortion, when it will occur? When the input signal and output signal is not linear. So if the bandwidth of the signal xt, which is to be transmitted over a non-linear channel, is b hertz, then due to the channel non-linearity, the bandwidth of the output signal will be capital K b hertz. So this way the non-linear distortion that can be occur, and due to that the signal xt that can be changed from xt to the some other value, and the some constant that can be also multiplied with that particular signal. Thus the spectrum of the output signal spreads well beyond the input spectrum. I mean, if somebody has defined that this is my input signal spectrum, then my output that can be within this particular range. Then due to the non-linearity, the output signal spectrum that can be spread and it can be also changed. And whatever the frequency component which are not present in the input, they may also appear as the output into the signal. This additional frequency will change the shape of the output signal. So this type of the distortion that affects the amplitude modulation but does not affect the frequency modulated signal. This particular point that we will discuss in the next chapter, that is how such kind of the distortion that affect into the modulation, amplitude modulation, but it will not affect to the FM signal. distortion due to multipath effect. Here is the diagram. This is the transmitted tower and it is the tall building. This is my receiver. So we are transmitting the signal from the transmitter. So transmitted signal is received by the receiver via this particular path. I am naming that path as the direct path. Sometime it may happen that the signal transmitted from the transmitter will first of all go to this particular path and it will strike from this particular object and received by the receiver. So this is the path, that is the path number 2 and path number 3 that are the indirect path. So here you can see that while the signal that directly comes from the transmitter, there is no change in the parameter of the signal. But while the signal may travel into the various paths, there might be the change in the amplitude, change in the phase or change in the frequency of the signal. So it again provides you the distortion. So the two signals undergo different amount of the time delay, hence the phase delay before reaching to the receiver. So what is the net signal strength at the receiver? So that is the vector sum of the field strength of the signals received via the multiple path. So it is the path number 2 and path number 3 vector sum of that is the total signal strength. Next is distortions due to fading channels. It is a type of the degradation that occurs in the radio communication and it is considerably more prevalent in the mobile radio system. I'll give you the simple example to understand about these things. That when you travel by the train and when you are traveling by the train, you are talking with your friends, then what happens? The signal which comes to you that comes from the various obstacles. So the signals from the tower that is striked onto the particular obstacles and then it reaches to you. So due to that, the signal amplitude that can be changed. Sometime you know that the handoff will be not smooth than the signals that can be that you may not get while you are in the train. So what happened? That your call that is cancelled. So that is why such kind of the radio signals that can be affected into the mobile radio system. So this means the variations and the fluctuations in the signal strength in the receiver. There are the two types of the fading. One is the rapid or the slow fading. Another one is the general or the frequency selective fading. Distortions due to the fading channels. The slow and the fast fading refers to the rate at which the magnitude and the phase imposed by the channel on the signal changes. The factor influencing the fading, that how do you get the fading effect? That is due to the one reason is due to the multipath propagation. Multipath propagation, due to that the fading will occur. Speed of the surrounding object. When I given you the example that when you go by the train, at that time the object in which you are sitting, that is moving at the very faster speed. So while the particular object that is moving at the very faster rate, the signal provided by the particular tower that has been also changed, and due to that the effect of the fading we will get. So that is the another reason. Another is the speed of the surrounding object that we have seen. Transmission bandwidth of the signal, that the bandwidth of the multipath channel that can be quantified by the coherence bandwidth. And the coherence bandwidth is what? It's a measure of the maximum frequency difference for which signals are strongly correlated in the amplitude. So this is about the signal distortion which we have studied. Okay, so till now we are having this particular thing. Thank you very much everyone.